All right, folks. We are looking at exponential equations when we do not have a common base. So that's something we have to do is what's called using logs. All right, so let's first of all, let's review. So in this little review question right here, these can have a common base because, right, the base is going to be 6. So 6 to some power, 6 to a power, equals 6 to a power, and there's the x out here. That's right, 6 to what power? That's right, that's a 2. Then 6 to what power? That's right, it's a 3. Oh, I forgot my plus 3 here. So now that's right, we drop the base. That's right, 2x plus 6 equals 3x. Then we subtract, we get 6 equals x. Okay? So now let's look at this problem. Right, there is no power of 5 to equal 16. So this is when we have to use logs. So we literally, what you have to do is take the log of both sides. Okay? And then what we're going to do is the exponent that we have, this exponent, so we're going to take the log of both sides, and that literally just looks like this. I put the word log in front of here, and I put the word log in front of there. So I have log of 5 to the power of x equals log of 16. Okay? Now, we take that exponent, put the exponent in front. So that exponent now becomes a coefficient. And then we solve. It's a linear equation. Everything is done in the calculator. You need a calculator. Cannot stress that enough. All right, so this x goes in front, so I literally just write x log 5 equals log of 16. All right, now, what does all this mean? Log 5 is just some decimal that's in the calculator. When there's no base showing, that is saying log base 10 of 5, okay? This log of 5 right here, I'll write it out up top here. That log of 5 means there is some decimal, base 10. If there's no base showing, it's base 10. So this is saying 10 to some power equals 5. That's what it says, okay? There is no power of 10. There is no power of 10 to equal 5. It's going to be some of this god-awful decimal. And that's what your calculator can do for you. Either a graphing calculator or a scientific calculator. On this scientific calculator, LOG, there's our special button that we're going to be using. All right, here it is right there on the graphing calculator. Okay, so now, so if I type into the calculator log of 5, so this god-awful decimal. So what it's saying is 10 to the power of 0.698970043 blah, 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 blah is equal to 5. Okay? So if I just rounded this off, I'm going to round this off to the nearest thousandth. And I did 10 to the power of, I'm going to do 0.670. No, I'm sorry, 699. 699. Look at how close we are. 5.0034. Okay, that's awfully close to 5. So the more decimals I get in here, the more accurate this answer becomes. Okay, but that's what the log of 5 is. The log of 5 is just some god-awful decimal. So literally, when we are right here, we do everything in the calculator. Well, she'll work first. So this log 5 is some awful decimal. So all I have to do is just divide both sides by this awful decimal. But it'll let the calculator do the work. So this cancels out. So then we have x equals whatever this decimal value is. So get out your calculator, and then you're going to do log of 16. On my graphing calculator, I got to close parentheses, divided by log of 5. log 5. Hit enter, and there's my answer. We're going to round these answers off to the nearest, I think I did it in the homework, to the nearest thousandth. Okay, so we're going to round to the nearest thousandth, so that's 3 decimal spots. So 1.723. There we go. All said and done. Okay, that's all we have to do. All right, let's look at this next problem. So this one says 7 to the power of 3 over x equals 4. So there is no power of 7 to equal 4. So we're going to take the log of both sides. So 3 over, so we're going to write log of 7 to the 3 over x power equals the log of 4. Let's take the log of both sides. Now this exponent goes in front. So we write, where am I going to write this out? I'm running out of room. So we're going to write 3 over x log of 7 equals log of 4. All right, now I have a question to ask. Where's this x in relationship to the log 7? That's right, that log 7 is over 1, so it's on the bottom. So I'm going to rewrite this so it may be a little bit easier for us to see. I'm going to do it over here. So I'm going to write 3 log of 7, all of that, over x equals log of 4. Okay? And now how do I solve this? That's right, we cross multiply. So I multiply x times the log of 4. Okay? Now let me ask you this question. If I'm going to do x times the log of 4, yes, if you need to, put a 1 under here. Don't eventually have to divide by the log of 4? So I could just literally switch places with this x and that log of 4. So I can do this. 3 log of 7 over log of 4 equals x. Now, do I need to put it over 1? No, I don't. So I just got to type this into the calculator now. So then x equals whatever this is in the calculator. So I do 3 log 7, I got to close the parentheses, divided by log 4. Close parentheses, hit equal, and there's our answer. To the nearest thousandth, we have 4.211. Okay, that's it. Little fancy algebra there. All right, so let's go back. Let's look at question number 4 now. That's right, we're going to take the log of both sides. And when I'm taking the log of both sides, where does the exponent go? That's right, the exponent has to go in front. So I literally can just do 2x log of 6 equals log of 12. And now what do we divide by? That's right, we divide by everything here. What's the operation between the 2, the x, and the log of 6? It's all multiplication. So I'm going to divide by the 2 and the log of 6. All this cancels, so I'm left with x equals, now I just got to type it into the calculator. We have to type this into the calculator. Get some stuff in there out of the way. So I got log 12 divided by, now I have to, this is saying 2 times log of 6. So I have to say open parentheses 2 log of 6, close. And I'm going to close it one more time. Notice the first close is for that, the second close is for this. I'm going to hit enter. There's our answer, 0.693. Okay. Now, you could have done divide. We could have divided everything by the log of 6. So log of 12 divided by the log of 6. Okay. So I first divided by the log of 6, and then whatever this answer is, we can divide by 2. Now I'm going to take this answer and divide by 2, and that gives me my same answer, 0.693. Okay, so you could do, when you see something like this, the 2 log 6 at the bottom, you could do divide. First divide by the 2, then divide by the log 6. Or first divide by the log 6, then divide by the 2. Same thing. Okay, there we go. Nice and easy. You need a calculator. It can be scientific, it can be graphing, it does not matter. I'll do the next one with the scientific calculator. All right, this is 3.5 to the 4x equals 6. Who cares? What do? Right, 4x log of 3.5 equals log of 6. And what do? We divide by all of that. Starting to scribble a little bit here. So x equals, call it the scientific. Oh, I'll do it on that side so you guys can see. So I'm going to do that cleared out. I got to hold this up just right so I can see it. So I can't see what I'm typing with this. I don't know why this calculator has a little glare on it. I don't know what it does. I can't see what I'm typing in. All right. So we have log 6, so there's the log button. Notice the open parentheses, divided by, I'm gonna do big parentheses, 4 log of 3.5. 4 log, where's my log button? Log of 3.5. Close, close, hit enter. So we have 3.58, 0.358. So 0.358. All it is doing it in the calculator. Now, for those of you that are using your phone, if you turn your phone sideways, you have to do the number first, then hit the log button. So you'd have to do 6, then the log button. That's how your phone would have to do it. As I said, download that Calculator X. Nice, easy app to use. All right, if you're going to download Calculator X, make sure you download the version that looks like the graphing calculator. It's a freebie. Okay. All right, what do we have here? Now we're on question 6. It says radical 5. Who cares? So all of this is the exponent. 2x plus 3 is the exponent. So that goes in front. Use parentheses. Okay. Now, yes, I could distribute the decimal here. Log of square root of 5, but I'm not going to do that. What I'm going to do is divide by the log of 5. And I'm going to divide. So notice I divided by the log of square root of 5. Everything that you do now, it can be done in the calculator. All right, so think about this now. Once we come up with this god-awful decimal, what do? That's right, we subtract 3. You can do that in the calculator. And then whatever that answer is, we divide by 2. So I'm going to type that into my calculator. I'm going to use this one because I can see it. I don't have to stand up. So I have log of 14 divided by log, and I'm going to hit square root button, second square root, 5. I got to break out of that and close the parentheses. I'm going to hit enter. So right now I have a decimal. This right here is 3.279 ... So now algebraically, what do? That's right, we have to subtract 3. Well, there you go, minus 3. And then what do? That's right, divide by 2. Notice you're doing everything in the calculator. Divide by 2. And there we go. 0.140, right? 7 changes the 9, changes the 3. Nice, 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 nice and easy. All right, look at this number 7. That's a little bit different. What do you think we're going to have to do first? That's right, it's an exponential equation because the 5 is there and there's your exponent. All right, just like we did before. So we're going to add 8 first. So where'd 25 come from? That's right, I added 8. Now I'm going to divide by 4. And 25 divided by 4 is 6 point something or other. Make sure you guys can see it. 6.25. And now what do? That's right, we take the log of both sides. Right, x minus 3 needs to be in parentheses when you're taking the log. And just like what we did over here now. Okay, we're going to divide by the log of 5. And then we're going to have x minus 3 equals that big gobbledygook decimal. Okay? If you want to write it down, you can. I was just going to do it all in the calculator, but it looks like I started writing it out. So I have log of 6.25. So log of 6.25 closed divided by log of 5. Okay, so I got 1.1386 dot dot dot, and now what do? That's right, add 3. So plus 3. So x equals 4.139. Nice. Nice and easy. All right, last one. This is certainly different. That's different. Oops, now you can see it. That's different. Okay, so what do you think we're going to have to do here first? All right. If you have a calculator that can do this, you can easily type this into the calculator. My calculator can do this. Okay, I'm not going to show you guys. I want you guys to, use your rules. So first thing we're going to do is write this in exponential form. So that's right, exponential form. So we're going to do 5 to the power of x equals 28. Now it looks like just like all the other ones we've done. Okay, it could have been this one right there if I used 16. So we'll take the log of both sides. So x log of 5 equals log of 28. And then I divide by log of 5. So I'm just going to leave it just like that, right? Well, I'll divide by log of 5. So x equals whatever our decimal is. Log of 28 divided by log of 5. And 2.070. Okay. So now, you see this right here, what we did? Now, look at how it says log of 28 over log of 5. There's an actual rule when you see something like this. It's called change of base. And I'm going to show it to you on the other side. The change of base rule. And what that means is this. Okay? It's this thing right here. Log base A of B is equal to the log of B over the log of A. Because think about what we just did. We had log base 5 of 28 was equal to x. We did 5 to the x equals 28. We took the log of both sides. And we divided by log of 5. Look at that. That's what we did. Remember that? We just did it all on the other side. So look at what the change of base formula says. If I have log base A of B, I can easily just say to solve this, I can just say, hey, the log of B divided by the log of A. So this right here, we could have just done log of the top, log of 28, divided by log of 5. And that would have given us our decimal value that we typed into the calculator. Oops, let me clear that out of the way. It was right there. Log of 28 divided by the log of 5 is our 2.07. Okay? That's your change of base formula. Okay? You're going to see 1 or 2 problems like that on the homework. All right, folks. Alrighty, guys. Have a good day.